guys, this is the last video in chapter 8. We're going to do titrations and then some redox reactions, both of which are going to come up in Chem 2. So a titration, that's a substance, well, in a titration, we take a substance with a known concentration and we react it with a substance of unknown concentration. And we normally do this in a burette. And burettes count down instead of up like most equipment. This was what was used in your Sig Pogel at the beginning. Okay, and sometimes we use an indicator which shows us a color change when the pH or the acidity changes. The end point shows us it happens when that color change happens, but what we really want is the equivalence point, which is when moles of H plus are equal to the moles of OH minus. So here it's showing you a titration. Sorry, my dog decided he needed to get in and out of his crate. So we've got the burette here. We've got the top piece is the burette. We've got hydroxide in the burette, and we're dropping it into the acid. And the more hydroxide we drop in there, some pink starts to form. You can see that there. And then once we get to the equivalence point, remember that's when the color change happens, it's going to be all pink. And we really want it to be a light pink. Once you've gotten a hot pink, that's too much. This is a real-life image of how this happens. Really, that equivalence point is too much. But again, it's that pink solution. If we were in lab, I would tell you that that was too far and you would need to do it again. But this is just showing you for color purposes. In between, there will always be some color and then it'll swirl out because you'll have a stir bar in there. All right, so we've got a titration problem. It wants us to do, and remember, we're looking for the equivalence point, which is in moles of H plus is equal to moles of OH minus. So I've got OH minus. Here's my H plus. Remember, when moles were equal, we could do M1V1. So really, this is MAVA is equal to MBVB. It is important to note that this only works with a one-to-one reaction. When it doesn't, you've got to do the solution stoichiometry. So I'm going to do it one way, and then on another problem, I'm going to use solution stoichiometry. So my moles of, or my molarity of my acid, I don't know, but I do know the 10 mils of HCl is equal to my 0.1 moles of base, molar, and 12.54 ml of base. Just remember, as long as they're both milliliters, you're good to go on the dilution. And I get that molarity of acid is 0.125. And that's of HCl. It is important to note which one. And the reason I only have 3 sig figs is because this number right here is 3 sig figs. The other 2 are 4, but that one is 3. Okay, so here we have one that is not one-to-one, which is good because we need to truly do solution stoichiometry. So I have H2SO4 and I have KOH. If you do not have an equation, we need to write one. So I have H2SO4 plus KOH yields water and K2SO4. I need a balance. I need a 2 here and a 2 here. Okay, so once we've got that, this just becomes a solution stoichiometry problem. And we start with our volume. You need to start with the volume that you have a molarity for. So I've got 22.87 mils KOH. Remember, if you've got mils later, you can leave it. Sorry, I don't know why I put that there. That should be liters on the bottom. 1 liter KOH. Ugh, I love that. and then 0.158 moles KOH. Now we do our mole ratio. So I have 2 moles of KOH to every 1 mole H2SO4. For this one, this is where we stop because I need to find moles and then I can find molarity. So I have 22.87 times 0.158 divided by 2, and I get 1.807, and this is actually millimoles. So when I divide that by milliliters, the millis cancel out. All right, and then once we solve that, I get 0.0903 molar, and remember that's of our H2SO4. So just remember, if your moles of H and OH in your initial equation are not equal, not 1 to 1, then you're going to have to do solution stoichiometry. If they are, you can use the MAVA is equal to MBVB. Okay, now we're going to talk about gas evolution reactions. All I need you to be able to do is recognize them, okay? And all it means is that a gas forms, so it's going to be a product. So here, gas evolution. Here, gas evolution. Okay, gas evolution. And all of these have a gas evolution. Okay, you will not be expected to predict that just in like a multiple choice. If it was there, you need to be able to say, yeah, this is a gas evolution reaction. So you don't have to write them. Now we're moving on to redox. Redox is super important, and it's an entire chapter in Chem 2. It's chapter 19. So again, very important. Also, there's a class that's mostly titrations and redox in your junior year level if you're taking that high of chemistry. Okay, so redox is when electrons are transferred from one thing to another, and redox is just an abbreviation for oxidation reduction reactions. Okay, so here it's showing combustion as a redox reaction. So the way to know if it's oxidation or reduction is the acronym LEO says GER. So LEO is loss of electrons is oxidation. GER is gain of electrons is reduction. So here we're losing electrons, are coming out, oxidation. Here we're gaining electrons, are going in, reduction. Also, oxidation is an increase in oxidation state, and reduction is a decrease in oxidation state. We're about to talk about the rules of oxidation states or oxidation numbers. They're called either one. But notice here, the one that was oxidized went from 0 to +4. The one that was reduced went from 0 to -2. So oxidation states are similar to charges, but they're imaginary charges that are assigned based on a set of rules, as where ions are the real charges. All right, so it is very important that you write all of these down. All right, so free elements are always going to have 0. A free element is any element that's just the element. You could have multiples of that element like Cl2. Also S8. Any of just a single element is going to be 0. Free element. If it shows a charge, it's equal to the charge. That's rule 2. Rule 3 is the sum of a compound is 0. So NaCl shows no charge, sum is 0. The next one, the sum of an ion is equal to that charge. So here I've got NO3 minus, and the sum is equal to -1. Group 1 metals are always +1. Group 2 metals are always +2. Rule 5 is using this table, and the table goes in order. So these rules 1 through 4 are always rules. Rule 5, if something else is in rule 1 through 4, it takes precedence. Okay, and the table, again, it goes in order. So fluorine takes more precedence than group 6A. Hydrogen takes more precedence than oxygen. Okay, so we've got some problems. A, Cl, free element, 0. B, that is rule 2, where it's +1 because it shows a charge. C is our first one that is a sum problem. K is a group 1 metal, +1. I'm going to call F X because I don't know it, and the sum has to be 0. So K is +1, F is -1. D, I've got CO2. The only rule I have is that it has to equal 0, but I also know that oxygen, because it's got a assigned number, could be -2. But there are 2 of them. Please make sure when you do the sum, you add them, because there's 2 oxygens, you have to account for that. So here, carbon is +4, oxygen is -2. It is very important to note, while the sum of oxygen in that problem is -4, 1 oxygen is -2. Okay, so SO4 2-, so I know that oxygen's -2. I've got 4 of them. The sum has to equal -2 because that's what the charge is. So I've got 1 sulfur. So I believe sulfur comes out to +6. Oxygen is -2. F, got K2O2, no charge shown, so it's equal to 0. K takes precedence, +1, that's rule 4A. There are 2 of them, which means O cannot be -2. So I've got 2X for O. For this one, K is +1, O is -1. This really just takes practice, so if you need more help, let me know. Again, this will appear again in Chapter 19. And depending on who you take for Chem 2, they may not reteach you these. Okay, so let's do like E. I'm going to do E down here. So SO3, I know that oxygen is -2, so I have X, I don't know. Sulfur, and it's equal to 0 because this one does not show a charge. So that means sulfur is +6, oxygen is -2. Let's look at F. Equal to -1, I've got 3 times -2 plus X. So nitrogen is +5, oxygen's -2. All right, so you really need to know how to do that because when we get to reactions, you need to be able to very quickly give oxidation numbers. Okay, so these 2 are 0. Hydrogen's +1. Magnesium's +2. Oxygen's -2. So you're looking for what changed. So magnesium went up and hydrogen went down. So hydrogen was reduction, magnesium was oxidation or oxidized. Okay, so I would say Mg is oxidized. And I would say H and H2O is reduced. It is important that you know only reactants are what you call oxidized or reduced. The products are something else, which we are not discussing. All right, let's do another one. Tin is 0. -2 plus 4. So we can see already tin went up, oxidized. -2 plus 1 plus 5. -2 plus 4. So here we can see nitrogen is reduced. They do have to have both oxidation and reduction unless it's a half reaction. Okay, So the bottom is just asking, are they redox reactions? For this part, whether it is or not, you're looking for the one that is not double replacement, which are two compounds and the compounds are switching spots. So if you look, or the elements are switching spots, normally the cations. A is double replacement, so this is no, not redox. The bottom two are redox. So aluminum is 0, it goes to plus, so Al is oxidized. O is reduced. Same thing here, O should be, O is fine. Calcium +2, C is 4, 6. Okay, this one is actually also no. But it's just based on the charges or the oxidation numbers. Okay, so agents are kind of confusing. I will not test agents at all. The agent is what causes the other thing to happen. So like here, sodium is oxidized. The reducing agent is sodium because it's causing the other one to happen. It's causing chlorine to be reduced. Okay, but again, I'm not testing agents. All right, here it wants us to identify agents. I just want us to identify, is it redox or not? So yes, redox. No, yes. Okay, B is not because it's neutralization, which is double replacement. A is not double replacement. B is not double replacement. C is not. It is double replacement. And then D is. Okay, please remember, transfer of electrons doesn't have to be a complete transfer. They just have to be moving. Okay, there are redox reactions without combustion. This one specifically is a synthesis reaction. Some people call it combination, but it takes two small things and it makes one large compound. Okay, and then the last thing for this chapter is activity series. These help predict whether or not that redox will happen spontaneously, which means will it happen on its own or will it not? Okay. So this is an activity series. I do not have any test questions on this or quiz questions, but it is good to be able to read this. So if it is higher than the one, so single element is higher than compound one, then it will be spontaneous. Okay, so let's look. I've got iron and magnesium. Is my chart going to pop up? No. Okay. So for iron and magnesium, which one was which? Iron is my single element. Magnesium is in my compound. So is iron higher than magnesium? So the answer is no. So that one is not spontaneous. For B, is iron higher than lead? Lead is down here. Yes. If the single element is higher than the element in the compound, it is spontaneous. Okay, is zinc higher than nickel? Zinc and nickel. Yes, so that one is spontaneous. Is zinc higher than calcium? No, calcium is higher. So that last one is going to be not spontaneous. Again, this part won't be on the exam, but okay. If y'all have any questions, y'all just let me know. Y'all have a good day.